converter unit. It is convert the power to the as per the requirement of the motor. Means it is a high voltage, low voltage, constant current, constant voltage. These are the charging parameter or driving parameter of the electric motor also. The motor are used the BLDC motor in two-wheeler application. In three-wheeler or four-wheeler, it goes to the PMSM, permanent magnet synchronous motor, SRM motor, switch reactance motor like that. This is the architecture diagram or construction diagram of the electrical four-wheeler. So what is the main component in electrical vehicle? So basically, the main component are the battery. It is called as a traction battery. Second is the electrical motor. Third is the power converter unit and battery management system. In two-wheeler, in four-wheeler IC engine and four-wheeler electrical vehicle, the 60% component are same. Means in four-wheeler we use the glass windows, headlight, indicator, lamp, wiper system, cooling system. Okay, the 60% component are the similar in a IC engine vehicle or electrical vehicle. The 60% component are same. Though other than that, we use the DC-DC converter, charger, auxiliary component, and thermal management system. Okay, these are the component are used in a electrical vehicles. So we discuss about the one by one and in brief discussion of the each component of motor, battery, controller, battery management system, DC-DC converter, and some auxiliary component also. So first we discuss about the battery. The battery is nothing but the store the electrical charge. Basically, it is store the DC charge. Means it is store only a DC supply. Because the AC has been gradually increases, decreases. It is sinusoidal wave. Clear? So in 1 second, it goes to the 50 hertz frequency. Okay. So at a time, they are 50 times positive or negative. It is quietly impossible to charge the battery through a AC supply. So that's why we use the DC supply to charge the battery. So primary, it is two types of the battery, primary battery and secondary battery. So what is by primary battery? The primary battery, it is nothing but the battery are used only one time. Means like a cell. The cell are used in a remote, okay, in a clock. These cells in coil cell also. These cells are used only one time. They can put up, then it use, then it is discharged, it throw away. Okay, it is a wastage. It is a primary battery. Means it is used for only one time. The next type is the secondary battery. Secondary battery is nothing but it is used many times. Means it is a charge, use, after the discharge, then again charge, again use. It is like a mobile battery. So mobile can fully charge by the using of the charger. Then a battery can goes to the 100%. We use the battery of a mobile. Then discharge the battery. Again, we use the charger and charge the battery. It is a secondary type of battery. It is a charge or discharge and use the number of times. So most probably we use the lithium ion battery. Okay. So these are the batteries, types of batteries in electrical vehicle are used. First one is the lithium iron battery. Second is the nickel metal hydride. Next is the lead acid battery. Next is the thermal lithium iron phosphate. And last one is the nickel metal cobalt, NMC. These are the many types are in electrical vehicle batteries, but most of common that these 5 batteries, types of batteries are used in electrical vehicle. In now recent trends, we use the lithium iron battery because the lithium iron has the more battery life cycle. The battery life cycle is large and also the power density, it is also large. But in some cases, in a European country, The most probably are used in a NMC, nickel, metal, cobalt. These batteries are used. These batteries are in a some chemistries are used. Some nickel batteries are used for the higher long life cycle. Nickel has the high power density. Lithium has the less power density. Depends upon the their applications and their properties. We use the battery. In Indian market, we use the lithium iron batteries. So these are the structural diagram or architecture diagram of the batteries. First one is the cylindrical cell, second is the pouch cell, and third one is the prismatic cell. This is a you see in a picture, the cylindrical cell has in small cell. We can use in a remote control and clock. Okay, in that this is a cylindrical battery. It is shaped as a cylindrical. That's we call as a cylindrical cell battery. Next is the pouch cell battery. You see the picture. These are the use in a mobile. This is pouch cell, and last one is a prismatic cell. It is like a prismatic cell. The structure of the cells depends upon the application and customer requirement. We use the these types of battery. So most probably in a electrical vehicle, we use the cylindrical cell battery, because in a cylindrical way, it is help to the easy to design the battery pack and easy to handle the cells, and also the any thermal management system are used in a battery. It is effectively work in a cylindrical cell because the surface contact of the cells are very less. We use the prismatic cell, the surface contact will be increases. That's why they are affect to each other. So we use the most probably cylindrical cells also. Next one is a battery management system. So battery management system, it is a BMS. It is a manage the battery parameter. It is a nothing but the protection device of the battery. So nowadays, you can see the electric vehicle can be burned or battery can be burned. So main fault of this firing, extinguish fires or any failure of the electrical vehicle is the battery management system, because the chemical reaction is present or chemical reaction is happen in a battery. So it is a overcurrent, over discharge or overcharge. It is a drag by the maximum current. It is a underload condition. It is a overload condition. The battery parameter has changes. It will affect the directly goes to the battery temperature. Means temperature can be gradually increases. The temperature can be gradually increases. Some point the battery can be blast. Okay, it is flammable or flammable. So that's why we use the battery management system. The battery management system is nothing but it is a protective device to protect the battery of abnormal condition like over voltage, over current, higher temperature, over discharge, okay, depth of discharge, deeply discharge or over discharge. So we use the battery management system. It is nothing but it is the electronics component. Is you see in a picture, it is a simple electronics component. We use the controller. Sometimes are used the Arduino also. The programming process our embedded system are used in a BMS to measure all the parameters in a battery of a current, voltage, temperature. They are indicates to the consumer or who are the driving of the vehicle, and they take also the actions of the overcurrent. The battery can absorb the overcurrent, or it goes to the deeply discharge or over discharge. They can indicate the parameter of the batteries. These are the these are the functions or objectives of the battery management system. Now we discuss it is the protective device. Means battery is the major part in electrical vehicle. So it is necessary to protect for the abnormal condition. We use the BMS. It is a protective device or preventive device. It is a maintaining the battery system in reliable state. What is meant by this? In a battery pack designing, we use the number of cells. In 4-wheeler, it goes to the 1,000 cell also. In more also be more than the 1,000 cell. The each cell has been not a specifically has a charge. Means it is a some cells has the higher charge. Means it is a 80% charge. Some cells has a 50% charge. Some cell has a 20% charge. Means it is unbalancing. So BMS also has a function. They balance the cells. It is like both are used, passive balancing system and hybrid passive balancing system and active balancing system. These are balancing system are used for the in a BMS also. Why we are balancing the cell? Because some cells has been 80% charge and some cell has a 50% charge. The BMS can exactly or accurately indicates the charge of battery. So BMS can understand the average of the each cell. It goes to the 70%. So we can charge the battery. It goes to the 100%. So 50% battery, 50% cell charge only 70%, and 80% cells, 80% battery cells are go to the overcharge. All right, clear. So this is the overcharge and undercharge. It will affect the battery performance. That's why we use the maintaining the battery system. Next is the real-time data calculations. Means we discuss the SOC. Next we go to the SOC, means state of charge. And they are indicate the real-time data. Means what are the charge or how many charges or what is the battery temperature, what is the battery voltage, what is the ampere rating are available, how many charge are available. These all time real data can be calculated and display in a dashboard also. So driver can also understand the battery charge or how many charge our battery are stored in a battery. So how long we go to the distance. Okay. Next is they can generate the report. Also the smart battery or smart BMS are can store the report also. Means they can store the real-time data to R&D purpose, researching purpose also. To finding the which parameter are affect the batteries. Means like it goes to the motor over voltage. Sorry, the motor or vehicle is goes to the overload. So which parameter can affect? Means it is goes to the overload. Can battery can or motor can drag the heavy current to the battery. It will affect the temperature. Okay. So we can understand the what how many load or which load are given to the vehicle. The battery can also monitor the operation and parameter of the charging and discharge. Means the battery can fully charge. It is indicate through a panel, or battery can deeply charge. It is also indicate to the panel. It is help to battery can not should be overcharged or not goes to the deeply discharge. Why? Because the battery can overly charge is also affect the performance of the battery, and battery goes to the deeply discharge, it is also affect the battery performance. So what is the range of the battery? So battery can minimum charge is goes to 20%. Means the battery is reduces 20% charge, we plug in the charger, and battery goes to the 80%. We remove 80 or 90%, we remove the charger, because it is a safety point of view. The battery can be never be charged beyond the 80 to 90% on never be discharged below the 20 to 50%. And what is the range of the temperature? The battery can perform the temperature, it is goes to the 15 degrees Celsius to the 35 degrees Celsius. In between them, the battery can perform well. After the goes to the maximum temperature above the 35, the battery parameter can affect, and the chemistry of the battery can affect also. So simultaneously, their performance will be the poor, and approximately the vehicle can be performed under there are specific rating. Next one is the electrical vehicle power train component. Main is the electrical vehicle, and the main component is the vehicle motor, EV motor. So previously we discussed what is the motor. The motor is convert electrical energy into mechanical energy. So you will see in a picture, this is the motor. This is the gear system or transmission system are used. This is the motor. Okay. Basically, in two-wheeler application, we use the BLDC motor, brushless DC motor. So why we use the brushless DC motor? Because we use the brushes. It is some friction part. Friction will be present in a stator and rotor, because we are given to the both side supply for the producing the fluxes of stator winding and rotor winding. Stator means it is a stationary part, rotor means it is a rotating part. Most probably in a motor, the middle part is the rotating and the outer part is a stationary. It is called as the inner run part. Okay. In most of the two-wheelers are used the outer run motor, means outer part is the rotating, middle part is the stationary. Okay. Like iQube, TVS iQube, Hero Optima. These motors are used for the middle run motor. Sorry, outer run motor. And Ola, Ather, these are the inner run motor. Okay. So in two-wheeler application, we most probably use the BLDC motor. Why? Because the battery can store the DC supply. It is easy to transfer the energy battery to motor, because both are operate in a DC supply. Okay. So these are the types of electrical vehicle. The first one is the permanent magnet synchronous motor, PMSM motor. Next one is the induction motor. This is nothing but a synchronous motor, means it is run as a constant speed. Okay. And induction motor. Okay. Next is the brushless DC motor, BLDC motor. It is last one is the switch reluctance motor, SRM motor. So about these motor, permanent magnetic synchronous motor and induction motor, these two motors are operate in a AC supply. Okay. So battery can store the DC supply, and these two motors are operate in a AC supply. So now we use the another converter. It is convert DC to AC. So let us assume the PMSM motor are used in two-wheeler. So what are the parameter can add? We use the charger to convert the AC to DC. We use the battery to store the charge, and then we another use the converter to convert the DC to AC. Why? Because the motor is AC supply operated. So it is another converter used. So motor or vehicle goes to bulk. Also another converter used, the vehicle cost will be increases. That's why most of the applications in two-wheeler segment, the BLDC motor are used, because it is easy to transfer the power. DC, storable battery, and directly goes to the motor. It is easy to transfer DC to DC. But in a four-wheeler, it is a wide space. You use the large space. So and achieve the maximum load, because in a four-wheeler, load can be maximum heavy load. In two-wheeler has been used the less load application, approximately goes to the 200 kg maximum. So that's why we use the BLDC motor. Next is the PMSM motor are used in a Tesla model, Tesla or Tata Nexon, these, Tata vehicles also, PMSC motor. And induction motor are used in a Tesla model. The switch reluctance is the new innovative motors. It is a name as the switch reluctance motor. What is meant by reluctance? It is the opposition of flow of flux. The another terminology is the resistance. It is known as the opposition of flow of current. The reluctance is the nothing but opposition of the flow of fluxes. So we achieve the maximum torque. It is necessary to absorb the maximum fluxes, because flux is directly proportional to the torque, and torque is directly proportional to the current. They are three parameters are directly proportional. So we achieve the maximum torque, we achieve the maximum fluxes. So we use the switch reluctance motor. The switching process, it is reduce the reluctance of the motor. These motors are also operate in a DC supply. This is the innovative type of the motor. So it is convert induction motor into PMSM motor. PMSM motor converts into synchronous motor. Synchronous motor also they are after that converted into switch reluctance motor. These are the conversion parameters. Next component is the BLDC motor. We discuss about their connections also. So you can see in a picture, this is the two type of motor. This is a mid-run motor. You see in a pump or in a home application, in a motor pump type, or used in this type of motor are used in Ola Ether. It is a mid-runner motor. Means middle part is the running. In the right hand side, you can see picture. It is a hub motor. Means inner part has the stationary and outer part is the rotating. It is a hub motor. Outer part is the rotating. This type of motor are used in a Hero Optima and also use in a TVS iQube. Okay, these are the connecting terminals. Basically, the main component is the temperature control pin. These are the three wires are used in BLDC motor. It is a YGB, Y, yellow, G, green, B is blue. This is the three wires are used to supply of the motor. And to identify the position of the rotor, because we achieve the desirable speed and measure the speed of the vehicle, we use the Hall effect sensor. The Hall effect sensor is nothing but the small semiconductor device. They can measure the position of the rotor for the switching the next phases. We use the Hall effect sensor. These are the basic wires are used in a motor. Next is the controller. Previously, we discussed about some basic of the controller. The controller is nothing but the control the component of the vehicle. Means they can control the speed of the motor. They can control the battery parameter also. Okay, they can receive the various signals from a Hall effect sensor, throttle sensor, reverse forwarding. These are the connections. You can see in the right side picture. These are the wires are used. These are the wires are used in a controller. So in left hand side you see the different controller. In the right left hand side sharp left hand side, this is the controller used in a 4-wheeler application, heavy load application. And these are the 2-wheeler controller. Middle one picture is the 2-wheeler controller. So basically controller connections are the motor connection you see in a picture. This is the YGB, yellow, blue, green, YGB. This is a 3 motor connection. Next, positive, negative battery. Okay. Next, the power lock. Okay, means we can using the key we can on the vehicle. These on supply or on signal is conveyed to the controller. we use the power lock system. This is a high brake, high level brake and low level brake. These are the braking system are used in electrical motor, electrical controller. Means it goes to the braking system. We can brake the first, means any obstacle in present in front of you, and you can drive the electrical vehicle. First of all, we disconnect the supply of the motor. After that, we apply the brake. Okay? Because you apply the brake and motor can run. It is some friction between the vehicle and motor. It is harmful to the overall performance of the vehicle. That's why we use the electronics braking system also. This is the two types of braking system: high level braking, braking and low level braking. Next is the high speed, low speed point. The high speed, low speed means it is basically three types of braking. Speed means 3-speed stepping, means it goes to the 20 kilometer per hour, 25 kilometer per hour, 14 kilometer per hour. That's all. Next is the cruise controlling, means a vehicle can run the constant speed. Next is the Hall effect sensor. Basically, the Hall effect is nothing but the semiconductor. Hall effect is the device, semiconductor device. They can find the position of the rotor side. Next is a reverse forward and throttle. The throttle has the 3 wires. And next is the low brake system. Next, anti-theft means anyone can theft your the vehicle. They can indicate also. These are the wiring components are used in a controller. Next is a DC-DC converter. So why we use the DC-DC converter? Because already we have stored the DC supply, and we another use the DC-DC converter because the auxiliary component means indicator, horn, headlight. These auxiliary components are operating at 12 volt supply, and the battery can store the 48 or 72 voltage. So 72 voltage or 42 voltage, 48 voltage is directly connect to the auxiliary component. It will damage. So it is reduce the voltage, battery voltage to 48 volt to 12 volt, because the operation can run with the smoothly, because we can reduce the high voltage to the low voltage. We can use the converter. It is a DC-DC converter. Also we called as a buck converter. It is a two types of converter, buck and boost. Boost means it is convert low to high. It is a boost. Buck means high to low. It is a buck converter. So in you can see in a picture, basically 3 wires are used, 3 color coding: red, black, and yellow. The red is indicates the high voltage, means at 48 to 72 volt, and yellow is indicate to low voltage, and black is the return path, mean it is a connected as a ground. So sometimes in controller converter we use the fuse for the protection purpose. The specification of the converter is the 62 to 72 volt input side. Output is the 12 volt plus minus 0.3 volt. It goes to the approximately 10 ampere load maximum. The function is that to step down the voltage, high voltage to the low voltage, because the auxiliary component can work with only a 12 volt supply. So this is the comparison of the electrical vehicle, different types of the electrical vehicle. First one is the convenient vehicle. Next is a hybrid electric vehicle. Next is a plug-in hybrid electric vehicle, and last one is the all electrical vehicle. You can see in a picture, this is the IC engine vehicle. It is operate in only a fuel, petrol, diesel. They can emit the emissions, CO2 gases. It is also harmful to the environment. Next one is the hybrid. Hybrid means we are use the both IC engine also and electrical vehicle also. So comparatively in conventional vehicle, there are some less emission of the carbon dioxide. So we use the hybrid electric vehicle. Next is the plug-in hybrid electrical vehicle. Plug-in hybrid electrical vehicle means the battery can charge to the external supply. Battery can charge to the external supply by the using of the charger. So what is the difference between the hybrid electrical vehicle and plug-in hybrid electrical vehicle? The hybrid electrical vehicle, the energy source is the only a fuel. Means the energy source is the only a fuel. The fuel can run the IC engine. The IC engine run two parameters of vehicle and battery. Means IC engine also coupled to the generator. They can convert the mechanical energy into electrical energy, and this electrical energy use the charge the battery. Okay, they can use the charge the battery. So it is in a hybrid electrical vehicle, it is not use the separate charger. The battery can charge through the IC engine. Okay, next one is the plug-in hybrid electrical vehicle. So plug-in hybrid electrical vehicle is the we use the two sources of energy. First one is the fuel and second one is the charger. The fuel can run the IC engine and charger can use to charge the battery. And last one is the all electric. All electric means the vehicle can run only a electrical supply. Only electrical supply means we use the only a battery, not any IC engine, any combustion engine. We use the only a battery. The battery can charge only a charger, not using the any IC engine. They can charge the battery. We use the only electrical vehicle, only use the electrical battery. It is called as all electric. So now discuss what is the disadvantage of the electrical vehicle. Advantage of the electrical vehicle. So it is a low noise. So main purpose of use an electrical vehicle is the low emission of the carbon dioxide, because it is harmful to the earth and global warming. So government can give to the subsidy also. FAM, FAM, it is goes to the subsidies. We use the 80 to 90% of the electrical vehicle component, Indian component. The government can give to 30% of the subsidy. Means the vehicle cost is goes to the 1 lakh. The subsidy is goes to the 30%. The cost of the vehicle is decreases. It goes to the approximately 17,000 rupees. Also, there are less mechanical component or friction component. That's why it is a low maintenance, low running cost, because the friction or oil component are less. That's why that's why it is a low running cost. So in a electrical vehicle, we use the most of the electronics component for the controlling purpose. So it is a necessary to software connectivity to charge the battery or identify the charging parameter or BMS parameter of the battery. The AI system also used in electrical vehicle to communicate the vehicle, each of them. So self-driving system are used. It is a positively the climate, because no emission of the carbon dioxide, not emission of the carbon. That's why it is a positively impact to the climate. Also, there are the free license right, means the speed of the electrical vehicle is below the 25 km/h. It is not necessary for the driving license. So these are the vehicles are used in village or any commercial to transport the goods one station to another station. This type of electrical vehicle also we use. So these are the advantages of the electrical vehicle. So now, what is the reason behind it? The electrical vehicle not be gradually increases. Some challenges are present in an electrical vehicle. First one is the vehicle purchasing cost. So vehicle are run in basically three parameters: motor, controller, and battery. The most of the vehicle cost, it is approximately 50 to 60% cost of the vehicle is the battery. So battery are made in a lithium ion, nickel material. It is a rare material. So that's why the vehicle cost will be high. Purchasing cost will be high. Range also, because the store the charge in a battery, it is a limited, means it is required more space for the large battery storage. So it is a range problem, because the higher battery storage, it is goes to the higher range, and less battery storage, it goes to the less range. And next one is the limitation of the charging infrastructure and also the charging speed. It is a normally we can charge the electrical vehicle or battery. It goes to the 4 to 5 hours to charge the battery, normal speed, normal range. And we goes to the fast charging, it take the 2 hours, or some battery take the 40 minutes to charge the 80% of the battery. Next is the charging infrastructure, because it is a lack of charging infrastructure, because anywhere it is available for IC engine. IC engines means fuel, petrol or diesel. They are available approximately every 10 kilometer. It is a petrol pump, diesel pump also available every 10 kilometer. But in a charging system of the electrical vehicle, it is not available for a broad way in overall India. It goes to the approximately 100 kilometer or 50 kilometers, one station are available for charging of the electric vehicle. But also next is the disadvantage is the timing, because the charge the electrical vehicle is a normal speed or normal range. It approximately take the 4 to 5 hours of the charging of electrical vehicle. These are the disadvantages or challenges of the electrical vehicle. So we discuss about the different parameters of the electrical vehicle, like advantages, disadvantages, challenges, and what is the component, and the function of the each component. So these are the today's topic, future trend in electrical vehicle. Thank you so much for attending the webinar. Any questions? Any questions of today's webinar? Please mention in a chat box also. Anyone has any questions regarding the electrical vehicle?
If you have any questions regarding this webinar, you can ask from our expert. They will guide you much better. I think everyone have got their doubts clearly. I hope. So here is an overview video of ISI India. Please watch this.
Driving sustainability and fostering innovation have been the heart of ISA India's journey over the last decade. As the largest skill development organization in sustainable mobility in India, we have made a profound impact spanning 24 states and reaching communities across the country. Since 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through our state of the art Center of Excellence, skill development programs, faculty development programs, corporate training sessions, CSR activities, and a wide spectrum of courses with live and recorded interactive classes, we have empowered individuals with the future ready skills. Additionally, through national and international e mobility events such as the Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, and the e bike design challenge, we have provided a transformative platform for over 4 lakh students from more than 750 colleges and universities to showcase their innovative projects and ideas. Our unwavering dedication to excellence has been recognized with numerous prestigious honors, including the National Youth Award, Indian Star Award, Social Entrepreneurship Award, Titans of Technology Award, and many others. ISA India's initiatives have earned widespread recognition and support from the leading organizations such as NITI Aayog, MNRE, SMEV, AICTE, NSDC, and ASDC. Along with this, endorsement from over 100 plus automotive industry leaders and partnership with more than 900 academic institutions across India. The Center of Excellence, where education and skilling converge to drive innovation, skill development, and entrepreneurship. The Center of Excellence aren't just institutions, they are hub of innovation and transformation. With specialized facility for IoT and embedded system, drone technology, electric vehicles, and solar energy, our centers are designed to equip individuals with the cutting-edge expertise and hands-on experience in the technologies driving the future of mobility and sustainability. This is more than a center. It's a platform for empowering the next generation of leaders. Unite education, innovation, and industry to create an industry-ready workforce equipped to meet the demand of rapidly evolving EV ecosystem. We bridge the gap between academia and industry through cutting-edge research, hands-on training, and dynamic collaborations. Our center stands apart with its state-of-the-art infrastructure, from state-of-the-art learning equipment to cutting-edge hardware systems. Our facilities are designed to provide hands-on experience with real-world applications. Here, students and professionals work with the cutting-edge technologies like electric vehicle powertrain system, battery solutions, charging infrastructure, and a range of advanced testing prototyping tools and machineries, preparing them to tackle the challenges of tomorrow's electric vehicle industry. The center also offers hands-on experience with the real-world applications, enabling participants to work on EV components, testing procedures, and system integration, ensuring they are industry ready for emerging EV technologies and trends. The Center of Excellence caters to the diverse demand of government, academia, NGOs, and industries by providing a collaborative platform that aligns with their respective objectives. COE supports the government's vision for sustainable mobility and skill development by creating a skilled workforce equipped with the cutting-edge knowledge and practical experience in the electric vehicle technologies. It bridges the gap between theoretical knowledge and practical application. It offers academic institutions access to advanced equipment, research opportunities, and industry-relevant curriculum. By providing students with a real-world exposure, the COE enhances the quality of education and contribute to the growth of specialized EV program and research. The COE helps industries by providing industry-ready talent and fostering innovation through research and development initiatives. It collaborates with the businesses to address their technical need in EV hardware solutions, assist in workforce upskilling, and partners on R&D projects, enabling them to stay ahead in the competitive market. Not only this, it also collaborates with the NGOs to promote sustainable practices and provide training that empowers marginalized communities. We have successfully developed over 50 plus specialized centers that cater to the unique demand of government, academia, industries, and NGO. The center with Government of Assam Kerala, a Higher Education Department, Government of Kerala, Directorate of Skill Development, Employment, Odisha, MSME Technology Center, with academic institutions like IIT Mandi, IIT Roorkee, Kolkata University, LNCT University, Desh Bhagat University, MIT ADD University, UGI, CSMSS, EDCET, PES, and many more. In addition to this, we have developed the centers for industries such as Hero MotoCorp, L&T, and for organizations and NGOs including ICICI Foundation, EduNet, Govardhan Eco Village, and foreign agencies such as CRISNEL South Africa. Our goal is to establish over 250 plus centers worldwide by 2026, positioning India as a global hub for electric vehicle workforce. Whether it's an engineer, technician, or entrepreneur, our comprehensive training programs are something for everyone. From vehicle control system and IoT integration to energy management and autonomous vehicle programming, our curriculum covers every aspect of the EV ecosystem. These multidisciplinary courses ensures students gain the skills needed to excel in this fast evolving field. Through partnership with industry leaders, startups, and government agencies, we connect students to cutting edge projects and practical experiences. From internship to mentorship and collaborative research, our students gain direct exposure to the EV industry's dynamics. Our alumni are pioneers in the EV sector, designing cutting edge battery systems, leading research teams, and launching successful startups. Their journey starts right here at the Center of Excellence, where they transformed ideas into impactful solutions. We are committed to staying at the forefront of innovation and building a sustainable, inclusive future. Join us today and be a part of the electric vehicle revolution. Driving
Thank you for joining this webinar. I hope everyone has got this. If you have, if you want to purchase any courses related to electric vehicle, you can visit our website, which is given in the chat box. Thank you for joining this session.